Question 5 is the same as question 2, except now it's asking us to solve by resolving into force components. So we're going to start by drawing our diagram. We've still got 5 newtons acting on the horizontal axis. We've got 6 newtons acting at 60 degrees to that 5 newton force. And then we're trying to determine the third force by breaking it down into its components and then solving the components. So F1 is going to be equal to 5I because it's acting straight on the axis. F2 now is going to be broken down into its components. So it's got a magnitude of 6, cos 60 degrees is the I component, plus 6 sine 60 degrees is the J component. Now that can be further broken down into 3I plus 3 root 3J. Now, F3 is going to be our third force that we're not sure about, which is going to give us F3 cos of an angle I plus F3 sine of an angle J. Okay, so now all I'm going to do is group my like terms because I know that 0 should be equal to F1 plus F2 plus F3. So if I grab all my I components, that should be equal to 0. So 0 should be equal to, grab this, and grab this. 5I plus 3I plus F3 cos the angle I. Now I can start ignoring the i's. I don't actually do anything in this equation, but 5 plus 3 will make 8, and then I'm going to take that 8 to the other side. So negative 8 is equal to F3 cos theta. Now I'm going to get F3 on its own by taking the cos theta across by dividing. And now I've got F3 in terms of its own. Now I can start grabbing my other terms and solving for that. So 0 is going to be equal to 3 root 3J plus F3 sine theta J. Again, I'm ignoring the J components because that's just telling me what I'm looking at. So now I can put F3 back in here. So 0 equals 3 root 3 plus negative 8 over cos theta times sine theta. Okay, so from this point, all I have to do is chuck it in the calculator using solve n, and that's going to give me the angle. So here it will give me that theta is 33 degrees. Now that means that it is 33 degrees on the x-axis. So when I'm talking about what it's acting with the 5 Newton force, it's going to be 180 minus the 33. So 180 minus the 33 will give me 147 degrees. Okay, now I can find F3 by substituting this value back into this equation. So F3 is equal to negative 8 over cos of 33 degrees, and that is going to give me the square root of 91. And that is a Newton force. So now I can say that force 3 is acting against the 5 Newton force at an angle of 147 degrees and a force of square root of 91 newtons.